So first I swapped all the values and I am printing after the sorting array. Here I am printing before sorting array. In the slides also I said before only. So if I again recompile and run, you can see clearly it is printing the sorted array. There is no issue in that. But you if you know inside this stuff, inside unnecessary comparisons is also happening. To stop that unnecessary comparison, just mention minus I. Okay, now if you compile and run, let's see what happens. So after you mention minus I also, you can see the output is again showing the same result, that is sorted array. So there is no difference between this and this. Then what is the use of this placing minus I in the second loop? Means that is the nested loop. So there is a reason that I have placed minus I, that is to stop unnecessary comparisons. So I hope you understood how to stop unnecessary comparison in the bubble sort. So this is how you represent the power in the programming languages. Basically this is known as the order of big O of power of n, big O of n square. Basically this is. So basically bubble sort is not that much recommended because you have two for loops here. So with the help of only for loop, you can do in the other kind of sorting algorithms. So if this bubble sort is order of n square, if we have only 6 elements. Assume that you have 100 elements, 1000 elements. The complexity means n square here, 6 square 36. So that's no problem. So how this n square comes? Because the one loop gives you order of n. Inside also you have another for loop. So that's the reason you have n square. So suppose you have 100 elements. So 100 square, this is a large complex. So you should not handle this bubble sort with the largest elements. So another technique we have here, that is the selection sort. So before understanding the selection sort, we need to see some in the bubble sort only. So in the worst case, we need to consider that is order of n square. If whole array was reversed. If you consider the auxiliary space, that is for the space complexity, it is order of 1. Because we are not we are not taking any extra space to consume. Okay, in the original array only we are making changes in the bubble sort. Okay, now if you see what is meant by this selection sort. So selection sort is also order of n square, but it is very important to understand the difference between bubble sort and the selection sort. So there are some sorting techniques that might take order of n log n, which is compared less than the order of n square. But this selection sort also we need to understand. This is also a nested loop concept. But you see this is the original array. Suppose you have elements like 22, 13, 64, 12, 33. You want to make this array sorted to this format. So how you can do that? So in this whole array, you can check where is the smallest element. So the smallest element is 12. So you can take the smallest element of this array, swap with the first element. Understood? Swap with the first element. So after swapping, you can get 12 to the first element. So after 12, what is the smallest element of this whole array? That is 13. That is in the right position. So don't do that. So don't change that anyone. So these two elements are sorted. Now in this unsorted array, what is the smallest element? That is 22. So place this 22 to the next of 13. So I hope this makes some sense. So after changing this 22, after swapping these two elements, so up to here, this is the sorted array. So in this 64, 33, what is the smallest element? That is 33. So swap this 33 with that after 22. So this whole will give you the sorted array. So I hope this makes some selection sort. Now what is the importance of this selection sort? As this is also order of n square. So this is very important to understand the selection sort, because it is very simple. How you are selecting and how you are keeping the elements in spite of like bubble sort. It is coming like a bubble from the bottom of the lake to the top of that. So quickly I am going to clear the terminal and I am going to take this out the bubble sort code. So okay, all the remaining code, all the remaining stuff is same here. So if I remove this here also, say there is no error, because if we are printing before the sorting array, here we are printing after sorting array. If I compile and run, see, so it will printing before sorting array, after sorting array. Basically it is not sorted. So both the arrays are same. Now what I am going to do is I am going to introduce some logic in between here. So that logic is, I will say, selection sort. Okay, in this selection sort, what I will be going to do is, so I am going to have something known as here the min index in. So basically how we have seen in that slides, how we are going to take the minimum index, all the stuff like that. So I am taking the minimum index as the -1. It's not I, so take the minimum index as -1. Okay. So in the selection sort, what I will be going to do is, so basically I will be going to have a for loop. Inside this for loop, I will be going to have an I is equals to 0, and I will be going to go up to the size. Okay. I have calculated directly over here the size. Okay. So after calculating the size, what is the operation that you want to perform? I want to perform I plus plus. So if you want to descending order, you can start with the I is equals to the size. So you can go up to the 0 and you can do I minus minus. That is your wish if you want descending order. But in this case, I am going ascending order. So that's why I am having in this fashion. So to reduce the unnecessary comparisons or the last element, to get the last element, you can mention size -1. Post loop only I am going to set this minimum index to the I. So in this first loop only I am going to set the minimum index to the I. So there is no issue in this, I hope. So next inside this I am going to have another for loop. So I will be going to set j. So j is initialized with I plus 1. Okay, there is no issue, because if you initialize I with 0, you have to initialize with j is equals to 1, because you need to compare. Okay, after that you need to mention j less than the size. Okay, there is no issue in that. And the operation that I want to perform is j plus plus. So up to here I hope there is no issue. So inside this, for the nested loop, you are going to perform the comparison. You are going to say the minimum index, so that you need to compare with the nums of I. So that is as simple as this. So you need to just compare with the help of this if statement. So inside this if statement, what I will be going to say is minimum index that I will be going to set with z. So I will explain now. So first of all, you are going to initialize this minimum index with the first index, that is index of 0. I hope this is the minimum index with 0. So if you want, you can also have the minimum index 0 as well here. So there is nothing like this. Okay, so as you are going to initialize with minimum index with I, so every time you are going to initialize with minimum index I. So inside this nested for loop, what I am going to do is I am going to compare the nums of index I. So if you see clearly over here, so the first the nums of minimum index, nums of 0 is 5, and the nums of I here is nums of I here is the 5. Nums of minimum index is also 5. So both are same. So it will not be going to enter here. So after this, what I will be going to do is just I will swap the elements. So after the for loop, you can see clearly, I will not do here after the for loop. So after the for loop, I will be going to say, after this for loop, what I will be going to say is int temp is equals to nums of minimum index. Okay. So just for the swapping purpose, I am just doing, we already seen how to swap that stuff. So again, I will be going to start with the minimum index. So after that, I will be going to say nums of I. Okay, just put colon here. And after that, you are going again going to say nums of I is equals to 10. That's as simple as that. Already we have seen how to do swapping the stuff. So finally, we are printing the stuff in the terminal. Okay, see clearly what I have did is just nothing. So I am basically I am in the first for loop. With the help of this first for loop, I am going to assign the minimum index to the I. Okay, we have already declared here I is 0. So I am going to initialize this minimum index with 0. So inside this nested for loop, what I did just I am comparing the j with the minimum index of num of j's. So if you see this array nums of minimum index, so minimum index is 0 here. So nums of 0 is what? Nums of 0 in this case, our case is 5. Okay, we are comparing that 5 with nums of j. What is I plus 1? That is the 9. So we are comparing 5 and 9. So yeah, of course, the nums of minimum index is what? The first element. So the first element is greater? No, it is not greater. So as this is not greater, we are going to simply just traverse all the stuff, and we are going to, if the reverse is case, we are going to assign minimum index as j. Okay, after traversing all the stuff, that I am going to have this swapping thing. So I hope this makes some sense, because why we are not doing swapping here, because this is already swapped. If you compare these two stuff, then it will be going to not going to execute this one for the first two elements. So after it executing, we are going to swap these two stuff. Okay, it will be going to traverse all this array. It will be going to traverse all the array, and we are going to get some minimum index. So with this minimum index, we are going to have the swapping this kind of stuff. Okay, I hope this makes some sense. So after swapping the minimum index like this, and again we are going to call this. So that you can see here. So according to, so first of all, we are assigning minimum index in the first loop according to the row wise. In the row wise only we are swapping. So inside this next loop we are going to swap. So basically what I am trying to say is, with the help of this outer loop, so you are going to check all this stuff, and with the help of this loop we are going to traverse all the stuff, and we are going to get minimum index. So with the help of the minimum index, we are going to swap the stuff, and here in the outer loop only we are going to swap the stuff, and finally after completing all the array completion, you are going to have the printing in the terminal. If you compile and run, see, that's the stuff, the array is sorted order. This is the selection sort. I hope you understood. Select an index, place to the first, select an index, place in the second, select an index, place in the third, like that. the selection of the index that you are selecting is the smallest element. You can also select the largest element and keep that in the last, and you can also select the largest but one element and keep in the last, and like this the backward stuff also you can do. So if you see for the selection sort, we have the order of n square, worst complexity. So as bubble sort, this selection sort also have n square 1. We are not going to have any other stuff in this.